Okay, good day, everyone. So we're going to get started on a review for the test number 2. And then after that, I'm more than happy to answer any of your homework question, if you have any question. Okay, but before we get started, any concern or any issue you want to talk before? Okay. All right, so the review sheet has been posted, right? So if you go to the Blackboard, under the review for the exams, you'll be able to see the review for test number 2. And then you can open the file, it's a Word file. Okay. And let's go into the review questions first. Okay. Question number 1. So determine the price of 0 coupon bond that has a par value of $12,500 with a maturity date in 5 years. The interest rate is, for the competitive investment, the similar risk is 3.76% compounded daily. So here, compounding period daily. All right, so let me just maybe print the screen. Okay. All right. Now go to the note. Now I'll show you the detailed solution. Okay. Share the screen with you. So question 1 here, we just use a compound interest formula, right, to solve this. So basically it's a compound interest. Because 0 coupon bond doesn't pay dividend. So you just get one-time discount when you purchase the bond. So we're using compound interest formula to solve this type of problem. And for the compound interest formula, we need several things, right? So this par value is what we call the future value. It's 12,500. Okay. You know that. And then time t is given 5 years. Okay. And then also we have a interest rate, right? For the competitive investment, 3.76%. And typically you turn into a decimal number, 0.0376. Okay, that's interest rate. And then we also know its compounding period is daily. That means 365. All right. And now the future value equal to principal times 1 plus r over n to the nt, right? And here we're looking for the present value. How much is that worth? How much is 12,500 worth at the current moment, right? Okay. And now let's throw in all the numbers. So we get 12,500 equal present value times 1 plus, the rate is 0.0376 over 365. And then exponent is 365 times time t, that's 5 years. Okay, now just get p by itself by dividing both sides of the equation by the exponent. Okay. If you want to simplify 365 times 5, you can do that. But I guess I'll leave it there. That's fine. Okay, and then divide both sides of the equation by that same thing. 365 raised to 365 times 5. Now from there, the p is by itself, right? So we're looking for present value. So we just have to input this whole thing into the Excel and get a result. So now I'm show you the Excel input really quickly. Okay, yeah, it's opened. All right, so now it's gonna be 12,500 divided by the denominator is open parenthesis 1 plus rate is 0.0376 divided by 365, and now raised to the exponent is 365 times 5. Okay, and then close parentheses. So that's a complete input. Once you have the right input, the result should be correct. Here you go. So you run it to 2 decimal place because we're dealing with the money, right? So it's $10,357.37. So that's the final solution. 10,000. $357 and 78 cents. Okay. And that should be the final solution question for question number 1. Any questions? Okay, now let's take a look at question number 2. So the actual test should have about 10 questions, right? It should be 10 questions, and it's similar in nature, right? In terms of structure of the problems. And those questions mostly come from the homework assignment. So if you do well on the homework assignment, you should have no problem, right? Doing all these problems. So question number 2. So you can afford to pay $950 per month for mortgage payments. How large a loan could you afford if the interest rate is 4.05% for a 15-year fixed mortgage? And here, the hidden information is compounding monthly, right? All this mortgage is typically compounded monthly. And this is something hidden, but basically that's common sense. Usually, if you have experience or you're with a mortgage, your parents have experienced the mortgage, usually you make monthly payment. Very similar with your credit card, right? You pay on a monthly basis. So all these car loan, very similar settings. Okay, so now this regular payment, right? So 950 is what they call a regular payment. It's $950, that's given. So we're dealing with the mortgage. And mortgage is definitely an annuity, right? And it's a present value of the annuity. Okay, present value of the annuity. Okay, and the rate is given, right? The rate is 4.05%, and returning the decimal number should be 0.0405. Okay, and also we know time T is 15 years fixed mortgage, and then compounding period is 12 times a year. So once you know all of this, we apply the present value formula. Present value equal to present value of annuity equal to regular payment times 1 minus 1 plus R over N raised to negative NT, right? The exponent is negative, and dividing by R over N. Next step, we're just going to throw in all the numbers into the formula. Okay, regular payment 950. Okay. Okay. Times 1 minus 1 plus the rate is 0.0405 divided by 12 and raised to 12, negative 12 times 15. It's 15-year fixed mortgage. And from there, we have the denominator is 0.0405 by 12. Okay, it looks quite complicated, right? But usually Excel will help us get to the final solution pretty quickly. All right, so now let's throw it in. Okay, so 900 equal to 950 times the numerator is 1 minus 1 plus rate is 0.0405 by 12 and raised to negative 12 times 15, close parentheses, close the big parentheses for numerator, and dividing by denominator is 0.0405 by 12. Okay, and again, do it slowly, right? Because I have too much, we have a lot of experience doing this. That's why I could type it in pretty quickly, but you should always double check, make sure you have the right amount of parentheses, and then the operation symbol is good before you hit enter. Okay, now let's enter result, and it turned out to be this, and then we want 2 decimal place because we're talking about money, right? So it's $127,990 and then 53 cents. That'll give you idea, you know, how much per like borrowing power you have over this particular scenario. 127,998.53. So the final answer is $127,998.53. That's a borrowing power for this particular borrower. Okay. All right, so this is the first couple questions. Now let's look at question 3. The price of a bond with 20,000 par value and a coupon rate of 3.52% payable yearly. The bond matures in 10 years and the price will yield 4.78%. So this is market return, right? The return from the market. Okay, let's look at it. So this is not a zero coupon bond anymore, right? Because this bond, it pay dividend. You can also call it dividend bond. Usually, if most of the bond pay dividend, and all those bond pay dividend, you can call that dividend bond to distinguish that from the zero coupon bond. And zero coupon bond is a lot, compared to dividend bond, it's a lot simpler because you don't have two sources of income, right? Here you have two sources of income. First source comes from the par value. Okay. So we get to discount the par value, or like finding the present value of the par value. Okay, this is one thing, right? So first element is find out present value of the par value. Second element is find out the present value of all the dividend, right? Dividend is like interest. So all these streams of dividends, we need to discount that. So second source is the present value of all dividends. That makes it slightly more complicated. So present value of the par value, we use in the compound interest formula. So compound interest formula. Because just like the zero coupon bond, right? You only need to find out the present value of that par value and using the compound interest formula. And let's see what we have. So the future value of this investment of this bond is $20,000. And we know that the market rate is 4.78%. So on the average market, your money will grow at a 4.78% compounding yearly. And that's what this is talking about. And time t is 10 years. Okay, number of compounding period is 1, right? Once per year, 1 time per year. So now from there, let's apply the compound interest formula. So future value equal to principal times 1 plus R over N for NT. Okay, and again, plug in the numbers, present value times 1 plus the rate is 0.0. This is 0.0478 when you turn into a decimal number and divide by 1. And raised to n is 1 times 10, 10th power. All right, so we get 20,000 equal present value times 1 plus 0.0478 raised to 10th power. Now from there, we're just dividing both sides of the equation by this exponent. Now if you cancel that, present value should be equal to 20,000 by this exponent. And let's see what that is. And you can call this discount of the par value, right? So we discount it back to the present time, get a par value. So 20,000 divided by 1 plus 0.0478 raised to 10th power, 10 years. Okay. And that should give us the results, right? So this future value of 20,000 in 10 years is worth $12,538.51. So $12,538.21. Double check the number. 51 cents. Yeah. Okay, so we get to the first source of the bond price. Second source come from all these dividend incomes, right? Or interest incomes, if you want to say that. So also receive interest, right, on a yearly basis. So first one, let's find out what is regular payment, right? So it should be the interest rate, dividend rate is 3.52%, multiplied by $20,000. So it's going to be 20,000 times 3.52%. Let's see what that is. It should be about 700 something, 700 and change, but let's get to the detailed calculation. So 20,000 times 3.52%, $704. Okay. So that means you, on a yearly basis, you receive $704 as interest income. And also, what else do we know? We know the time t. You equal 10 years, and the rate is 4.78%. Okay. Number of compounding period is once per year. Okay. And now we're using the present value of the annuities because dividend is like the annuities, right? So you receive on an annual basis for 10 years. So the present value of the annuity equal to regular payment times 1 minus 1 plus R over N to negative NT divided by R over N. Okay. Now again, plugging on the numbers, regular payment is $704 on a yearly basis, 1 minus 1 plus 0.0478. So again, we always use the market rate to calculate the return, right? Dividend rate is only used one time to calculate the dividend or interest payment. Okay, then dividing by 1 raised to negative 1 times 10, negative 10 power basically. That's the numerator. Denominator is going to be 0.0478 over 1, right? Then you can omit that 1. It's not necessary to have that 1. So if you want to simplify a little bit to make it slightly simpler, 704 times 1 minus 1 plus 0.0478 raised to negative 10th power and over 0.0478. Okay, then let's see what that is. Let's go to the Excel, get a result. So it's 704 times 1 minus 1 plus rate is 0.0478 raised to negative 10th power, close parentheses. For denominator, you just divide by 0.0478. Okay. And that should do it. Okay, let's see what that is. So this turned out to be $5,494 and then 65 cents, right? That's how much this interest payment is worth right now. And that helps you determine how much you are willing to pay for the bond. Okay, so the total purchase, so $5,494 and then 65 cents. And combine those two sources of income, that's how much you're willing to pay for the bond, right? So adding those two. So the bond price should be equal to $12,538.51 plus $5,494.65. And this combined total, that's the bond price. And this turned out to be $18,600 So at the current moment, as an investor, you're willing to pay this amount for two sources of income. Okay, $8,033 and then 16 cents. Okay. Any question on this? Okay, let's look at the question 4, still about the bond price, right? So again, we get a price of the bond with the par value 10,000, coupon rate of 3.79%, payable every 6 months. So it's slightly different, meaning you receive interest twice per year, which is even better, right? The more frequently you receive interest, the better it is. And the bond matures in 10 years. It's priced to yield 4.55%. So the market return is 4.55%. So let's look at how we tackle this. Very similar procedure, but with a slightly more complicated scenario. So again, we're going to discount two things, right? We're going to do discount of the par value. So this is the first thing we do. Second thing is discount of all the dividends or interest income, if you want to call that. Maybe for a lot of people, interest income makes more sense. Dividend, you know, it's a more like a fancy term. Discount of dividends. Okay. Let's start with the discount of par values. Again, we're using the compound interest formula to handle this. So we know that the future value, this bond is worth $10,000 in 10 years. And the rate market return is 4.55%. So this is 0.0455. And T, that's 10 years. Number compounding period here will be 2 because you're getting paid interest every 6 months. So N equal to 2. So now we can use the compound interest formula, future value equal to present value times 1 plus R over N to NT. Okay. Now we plug in our numbers. So future value is 10,000. Present value times 1 plus the rate is 0.0455 over 2 and dividing or raised to 2 times 10, which is 20, meaning there are 20 semi-annual interest payments, right? From the corporate companies to the bondholders. That's what this means. Getting paid 20 times in terms of the interest. Okay. All right, so now the present value should be equal to 10,000 divided by this. So divide both sides of the equation by the exponent. On the left. You're going to simplify to 20, that's fine, right? It's 2 times 10 is 20, right? So make it slightly simpler. So the present value of this par value or face value should be, let's do the math. Okay, so it should be 10,000 dividing by 1 plus 0.0455 by 2 compounded twice per year and raised to 20th power. Okay. And let's do it. And let's see what the actual cost is. So it's $6,376 and 91 cents, right? So this is what that $10,000 is worth right now. 6,376.91. $6,376.91. Okay, so take care of the first part. Now let's move on to the second part. Let's find out how much is that all the interest payment worth right now. Okay, so with discount of all the dividends. So first of all, a dividend is like interest income treated like regular payment. So for that 10 years period of time, you receive interest twice a year, okay? And the total amount of times you receive interest 20 times. So the regular payments should be equal to 3.79% times 10,000. Okay. That should give us $379. Okay. You can put into Excel, get that, no problem. And also we know the rate. Rate is the same, right? Market return 4.55%, 0.0455. Time t is given 10, and then number of compounding period given 2. Now we need to know the present value of this annuity. So regular payment minus 1 plus R over N to negative NT. R over N. Okay. One more time, we will throw in all these numbers into the formula. So it's $379 times 1 minus 1 plus, the rate is 0.04455 by 2, and raised to negative 2 times 10. So negative 20 to the power for the exponent. And then the denominator is 0.0455 over 2. Okay. And this will give us the result. You just have to input it. Now go to Excel. So 379, that's the semi-annual payment, interest payment. 1 minus open parenthesis 1 plus 0.0455 by 2, and raised to, if you want to just put in, yeah, we can put in negative 2 times 10, right? That's fine. Close parentheses and dividing by 0.0455 by 2. Okay. And this is proper input. Now enter that. Then you get $6,035.83. Okay, this is $35. $6,035 and change will be 83 cents. Now, one more time, when you combine these two sources of income, right, that should be the bond price. So the final bond price, just adding those two, so $6,376.91 combined with $6,035.83, and that is what we have here. In terms of bond price, that's how much you are willing to pay for this bond as of now. So by doing all this calculation, you understand all this detailed information behind all these financial instruments. It also help you make the right decision, right? You don't want to overpay for this bond. You want to pay the fair price, and this is what they call the fair price of this bond, $12,412.74. Okay. And this is question 4. And let's look
so at I have a question on that.
Definitely.
So why would you pay like $12,000 when the bond is only for $10,000?
Okay, I see what you mean. Very good. Remember, this is not just only source of income, right? Remember, you also receive $379 for how many times? Times 2, right? Times 10, 20 times, remember? And this, if you multiply this, what do you get? 3. It's a very good question though. That's why, you know, there's a hidden, this is like hidden income from most investors. So actually, you are receiving a combined total of $10,000 plus $7,580. So the total income you receive at the end. Total return is this much. That's why you actually have $17,580 in your bond account, right? And think about this: for this amount of money, this amount of return, you only pay $12,000, $412, and $12,412.74. You still have a profit of well over $5,000 over 10 years period of time. So it's still, it's still a good investment, right? Although this one is not very obvious, but remember they pay you interest. You have to account that. All right, that is why. Okay, but it's very good, right? So you see through all these different complicated things, and then you realize, it's still a good investment after you compare. So again, if there are different like investment options out there, you should always compare the intrinsic value. This is the intrinsic value, right? And then how much you are willing to pay for it for a fair price, right? Okay, very good. And also let's look at question 5. So let's say your credit card carries 19.99%. That's very standard, right? If you open your credit card statement, most of the credit card, they charge you about over 20% actually. If you look carefully, they will say that API is 23.99% or 21.99%, 19.99%. This is pretty reasonable, for most credit card companies. And you want to pay off your balance of $6,700 with equal monthly payment over 5 years. So you decide to pay it off, right? You don't want to accumulate too much balance and affect your financial conditions later on. So how much should each payment be? How much total interest do you pay? So you can view this as an annuity because you have a lump sum payment, right, at the present time. The lump sum is $6,700. And you also are going to pay a regular payment over a 5-year period of time on a monthly basis. So the regular payment is what we're looking for. We don't know that, but we do know the lump sum at the present time, right? So present value of the annuity is $6,700. Okay. We also know the interest. Interest is 19.99%. So this is 0.199. Okay. Number of compounding period and the time T is 5 years. Okay. And number of compounding period is 12 per year. You're making monthly payments 12 times on a yearly basis. All right, now that what we try to solve for is the regular payment, and let's get to it. So present value equal to regular payment times 1 minus 1 plus R over N to negative NT and over R over N. Okay, now one more time, we're gonna put in the number first. So 6,700 equal to regular payment times. Maybe let me just reorganize a little bit. Okay. And we're going to use a proportion to solve it, right? It should be easy thing to do. We just scroll down a little bit. Let's go to the right a little bit. Okay, that should do it. So present value is 6,700. Regular payment, that's what we're looking for. So this is 1 minus 1 plus. Rate is 0.01999. To be honest with you, this rate is very super high. You wouldn't want to borrow from this type of lien holders, right? They charge you super high interest. It's not wise. We end up with charging you a lot of interest. So you should try to avoid using credit card, or you should try to pay it off on a monthly basis without accumulating the debt, because that debt costs a lot, right? Costs about 20% interest per year. So N is 12, T is 5. Okay. And on denominator, that's going to be rate 0.1999 by 12. Okay. And now what we do is make it proportion. And we just cross multiplying, right? Cross multiplying So R, and then that big square bracket goes to the left. So we get a regular payment times big square bracket. And if you simplify, you can simplify the exponent is -60. You can do that just to make it look slightly simpler. And on the right-hand side, 6,700 times 0.1999 over 12. Okay. Now eventually we just divide both sides of the equation by this square bracket. That will do it. And Excel will take care of this complicated calculation for us. And I cancel that. Square bracket, regular payments by itself. Okay, now let's do the math in Excel. Okay. So it's gonna be 6,700 times, no, we don't need parentheses for numerator. It's 0.1999 by 12. Let's do it. And divide by denominator. Or if you want to put this in the parentheses, no problem, right? You look a little bit weird without parentheses, so I'll put it in. Okay, and then 1 minus 1 plus 0.199 by 12. Yeah, and then raised to -60 power. If it's a single number, no parentheses needed. So we can just easily input it like that. That will do it. Okay. And just hit enter, right? We'll get a result. Here we go. So it's $177.47. That's your monthly payment in terms of to pay off this debt. And this is the first step, right? And they also asked us to find out how much interest, how much total interest do we pay? Okay, so now think about this. You are making a monthly payment 177.47 times for 60 times, 5 years, 12 times a year, that's 60 times. So you do $177.47 times 12, that's yearly payment times 5 for 5 years. Minus, you only owe 6,700 for now, right? So the remaining balance becomes interest that credit card company charge you. Let's go back here. So we're gonna do 177.47 times 12 multiplied by 5 minus 6,700. You'll be surprised, right? You're paying a lot for the interest. And this, you're paying pretty much about $4,000 just for 5 years. Every year you are paying about $800 just to pay for the interest, right? Just for the interest payment. And this is way too much. That's why, this credit card company really like you to, accumulate too much debt so they can charge you interest, keep charging you interest, and they can make more money, right? 3948.20. So this turned out to be $3,948.20. And this total interest payment you made to the credit card company over the life of the debt. Do you have any question on this? Okay, this is question number 5. Number 6. Refer to problem 5, right? So we still go back to problem 5, and another credit card company offer you a balance transfer option, and obviously they offer much lower rate, right? Otherwise you wouldn't be attractive. So they offer you a lower rate to attract your business. And how much should each payment be to retire your debt in 5 years? Similar condition. How much total interest do you pay? How much total interest do you save over the car with them? And this is pretty, again, this is pretty normal situation. A lot of people have this issue, and other credit card company will try to take advantage of this opportunity, but they And always you need to get to the numbers itself and to see if does it make sense to switch. And usually the credit card company will charge you one-time transfer fee, right? You also need to consider that. Sometimes the transfer fee is very low. Then if your savings a lot, that makes a lot more sense to switch. If the transfer fee is high, then sometimes it's not even worth to switch to the new credit company. But let's see how this goes. So similarly, the only thing differs from previous one is the rate. Rate becomes 7.95%. So we have the same amount of debt. Present value of the debt is 6,700. The rate is different now. It's right. Right. Rate is 7.95%. So this is 0.0795. And T is the same, 5 years, pay off in 5 years. Number compounding period is the same. Now, similarly, we try to find out what is the regular payment. It should be a lot less because the rate is much lower, but we never know, until we get the actual number, like how much lower that is. So that's just throwing on the numbers again, one more time. Regular payment times, we solve for regular payment, rate is 0.0795. So it's about 12%, about 12% lower, right? That's quite significant. And minus 12 times 5 years. Okay, again, you're paying interest for 60 times, right? Or making monthly payment for 60 times and over 0.0795 over 12. Okay. Now from there, again, we set it up as a proportion, then we cross multiplying, solve for the regular payment. So let's see what that is. So it's R times 1 minus 1 plus 0.0795 for 12 raised to negative 60th power. On the right hand side will be 60, so we do cross multiplication. Times 0.0795 by 12. So one last thing before we get to the actual number, dividing both sides of the equation by the square bracket. Same concept apply on the right hand side. All right, so cancel the square bracket, big square bracket, regular payment is by itself. And let's see what that number looks like. Okay, now 6,700 times open parentheses 0.0795 by 12. Okay, that take care of numerator and denominator is 1 minus 1 plus 0.0795 by 12 and raised to negative 60 power. If you want to, let's say you don't want to calculate anything, that's fine. Just let Excel do the work for you, right? Completely, just input it like that. Now you get this. Okay, so it's $135.69. If you just look at the face value, it's a lot lower, right? Compared to $177, you're saving $42 on a monthly basis. And that's your saving, right? That's how much you save over this life of the debt. $135.69. Now, next thing, let's find out what is total interest paid. You do 135.69, and you're making 60 payments like this, monthly payments, and you only owe $6,700. Now the difference is going to be the interest paid. And go back here, we do 135.69 times 60. minus 6,700. And let's see what that is. So now you look at it, you only pay $1,441.40, right? In terms of interest. And compared to the previous one, paying $5,494. So this is instant saving of more than $4,000, which is, no, actually this is the one. No, this is $3,948. So the saving is big. Right? You're saving yourself $2,500, right? Over 5 years. So every year you're saving $500 approximately. Okay. So if you go back here, it's $1,441 and some change. Let's see, 40 cents. And you can live with that, right? Because it's on average, divide by 5 is about $300 a year, not too much. But if you look at the previous case, it's a fairly large amount. No, it's, yeah, this. It's 3,900. Okay. It's $3,948.20, right? So then the saving will be the difference between those two. So the total savings, you're using the total savings. Will be 3,948. $3,948.20. Yep, and minus the current interest charged, it's $1,441.40. The difference is your saving. So by just simply using this, another credit card company could give you a lot of benefit financially. So minus 1,441.40, and the difference turned out to be $2,506.80. Okay. Basically, that's a lot of money, right? So you can buy a lot of things with $2,506.80 by just using take advantage of the other offer, and then you'll be able to do this. So always, think through this. Sometimes in your personal finance, it also help you make the right decision. Okay. Any question from the previous couple about the credit card situation? And now let's take a look at the APR, right? The APR is actual borrowing cost, meaning sometimes they give you nominal rate, but nominal rate does not represent the actual borrowing cost. APR is more accurate because APR would tell you, what is your effective interest rate is. So let's do some calculation on this APR thing. So you are given a nominal interest rate, meaning the interest rate without considering the compounding period. And then after taking into account of the compounding period, the interest rate usually slightly higher. Okay. And let's get to the detailed calculation. And you only need to use one formula, right, to do this. It's called effective interest rate. So for first one, part A, 8.34% nominal rate. And compounding period is daily, compounded daily. Okay. So let's see what's given here. The nominal rate is given, right? The I is given, 8.34%. No, I mean, let's use R. Okay. So this is R is given. The formula is listed on the PowerPoint, and the rate is given 8.34%, 0.0834. And time T is 1 year, right? And we usually don't even use that time T, because by default, we only consider within 1 year period of time. And number of compounding periods daily, that's 365. And that's all, right? So effective interest rate using I of E equal to 1 plus R over N to the nth power minus 1. Okay. 1 is the base, right? Assuming the nominal rate is 100%. And usually the effective interest rate is bigger than 100%. Okay, so this is going to be 1 plus 0.0834 by 365, compounding 365 times minus 1. I will give you the answer right away, because I'll use Excel one more time. Yeah, so it's going to be open parenthesis 1 plus 0.0834 divided by 365 close parentheses and raised to 365th power minus 1. And he entered, you get a result. So this turned out to be running to 4 decimal place, right? Just like what the question is given. So it's 0.0870. 0.08 approximately equal to. So this is approximately equal to 0.0870. So what they're saying is the actual borrowing cost is, or the effective interest rate is 8.70%, which is slightly higher compared to the nominal rate. That's always the case, right? And the more frequent compounding period, actually the rate is higher. The actual rate is higher. Okay, so this is part A. And then part B, let's see. Part B, we have 6.24% compounding monthly. Easy, we only need to know two things: rate, 6.24%, 0.0624. Number compounding period 12 per year. And that's all we need. And we just directly apply this formula. Effective interest rate I of E equal to 1 plus R over N to the nth power minus 1. And this should be 1 plus 0.0624 over 12 raised to the 12th power minus 1. And let's see what that is. So equal to 1 plus 0.0624 by 12 raised to 12th power minus 1. Okay. Have a proper input. Now good to go. Enter 4 decimal place, 0.0642. So 0.06. So turning into percentage will be 6.42%. You see, bigger. It's higher than the nominal rate. And the part C, we have 4.88% compounding quarterly. 4.88% quarterly compounding. Okay, the rate 4.88%. Quarterly meaning n equal to 4. 4 quarters in a given year. So now effective interest rate is 1 plus R over N raised to n power minus 1. Okay, and one more time, just throwing on the numbers, 0.0488 by 12 by 4. Yeah, not 12 anymore. It's 4 minus 1. And you will see it's still higher than nominal rate. Not by much, but still going to be slightly higher because it's compounding less frequently compared to daily. So that has some effect on the effective interest rate. And now once you input it, you get this. So it's 0.0497. Okay. 0.0497. That means the effective interest is 4.97%. You also see the effects of the interest, right, on basically on the return on investment. So the higher interest, you know, the higher return for the bank. So that means you have to pay more for the financial instrument, pay more for the loan, for the debt. So as a consumer or investor, you are at a disadvantage, right, for the higher rate. All right, so that's pretty much about the effective interest rate. And let's look at the question 8. So let's say I deposit $2,000 a month in the account, paying 5.23% for 15 years. You only deposit $700 a month in the account with the same yield for 30 years, double the time, but save a lot less, right? Save only 1/3 of the investment. How much will be in each account? How much total interest will each account produce? So this is very typical retirement account issue, and give you idea, you know, a comparison between invest longer with less money or invest shorter with much more money, to see the outcome of each scenario. So the first scenario part is 5.23% for 15 years. Okay, so this regular payment is 2,000. So we're talking about future value of the annuity, right? Because you receive this retirement distribution in the near future, in the future. So it's definitely a future value of the annuity, value of all the retirement account, right? Is a form of future value of the annuity. So regular payment $2,000. The rate is 5.23%. Rate is the same for both investments. So this is 0.0523. And time T is 15 years. The number of compounding period is 12 because you deposit on a monthly basis. Okay. So now let's see what is the future value of this investment. Okay. In your retirement account. So regular payment times 1 plus R over N to the NT minus 1. Okay, R over N, and denominator. So now one more time, we throw in all the numbers, 2,000 times 1 plus, the rate is 0.0523 over 12, and raised to NT will be 12 times 15, 180 payments of 2,000 minus 1, and dividing by 0.0523 over 12. Okay. And let's see what that is. So 2,000 times the rate, 0.0523 by 12, take a numerator and, no, not right. 1, open parentheses, 1 plus 0.0523, 12, and raised to 12 times 15. Okay, close parentheses, minus 1. Close parentheses for numerator and divide by denominator is 0.0523 by 12. Okay, and let's do it and see what that is. And it's turned out to be $544,969.27. 544,969.27. $544,969.27. So this is total ending balance in the account. And if you want to know how much interest accumulate in this retirement account, then we are going to deduct that from all the contributions, right, towards the account. So let's see what the total interest earned in this retirement account. Total return on investment, either way you want to call that. So this is total balance minus total contribution. So contribute $2,000 per month, and every year times 12, right? 24,000, and then for 15 years. Okay, and that difference should be the interest earned, or total return in investment. So it should be this 544,969.27 minus 2,000 multiplied by 12 multiplied by 15. And this turned out to be $184,969.30. No, 27 cents. Okay. So 184,969. $184,969.27. If you look at you see, this interest is 1/3 of that, meaning you contribute twice, the contribution is twice as much as the interest earned. You see, you contribute twice as much money, but you only earn one portion of that, right? Or 50% of that. So that's one scenario. This is first scenario. And second scenario is you start early. Let's say you start 15 years earlier, and then follow the same condition. Second one is $7,000 for 30 years at the same rate. Okay. And first of all, let's calculate the $700. So same rate, 5.23% for 30 years. Now the regular payment is $700. Okay. Rate is the same, 5.23%. So 0.0523. Time T is 30 years, twice as much. Number of compounding period is 12. All right, so now let's find out the future value of the annuity. Regular payment times 1 plus our N to the NT minus 1 over our N. Yeah. One more time, just throwing all the numbers into this formula. 700 times 1 plus the rate, 0.0523 over 12. And that's 12 times 30. So making 360 payments over the life of the retirement account. Divided by 0.0523 over 12. Okay. And let's see what this leads us to. Okay. So one more time, go back to this. Let's put it side by side to compare them, right? So this is $700 times parenthesis 1 plus the rate 0.0523 by 12 raised to 12 times 30. Okay. Although times is twice as much, but your contribution is not twice as much. It's actually much less. You'll see that in a second. It's just the total contribution is 700 times 360. And that's a lot less compared to the first case. And this is minus 1 divided by 0.0523 by 12. Yep. And once you input it properly, the results will be this, right? $607,996 and change, 39 cents. So actually you are totally better off with the second option. 607,996.39. 607,996.39. And if you look at the interest, you'll be more surprised. You see, you end up with a, again, first of all, more balance, right? In your, it's like 63,000 more in your retirement account. If you calculate the total interest earned, that's the actual difference, total interest earned. Total return from the retirement account will be 607,996.39 minus $700 times 12 times a year times 30 years. Let's see what will be the total return on this retirement account. So we'll do 607,996.39 minus 700 times 12 times 30. So your return is almost doubling, right? If you look at it, your return is doubling. And this matters more, meaning you make much more money by contributing towards your retirement account for a longer period of time. And this is the essence of the time value of the money, right? Over a longer period of time, the money grows much quicker. 355,996. And obviously you pick second option, right? Because it just gives you much more return on your investment. So once you graduate from college, university, you should contribute towards your retirement account as soon as possible, right? So in that case, you know, by the time when you retire, you have a significant amount of balance. Also, you have a lot of returns on your investment, right? So that's it's like pretty good advice, you know, for a lot of college graduates. Yeah. And question 9, the trust fund. Okay, so a lot of wealthy people has trust fund, right, for their loved ones or for their family members, and this is very common phenomenon. So trust fund is set with the goal of providing 30,000 semi-annual payments. So meaning this recipient of the trust fund will receive $30,000 every 6 months for 20 years. If the bank in which the fund is created can guarantee 6.38% interest over the life of trust, how much money should be deposited to fully fund the stream of payments right now, right? That's so the default information is how much money you have to put into account, put into a trust fund right now. So this is the present value of the annuity issue. So first of all, we need to identify what kind of a question they are trying to figure out. And here, definitely it's about present value of the annuity. You have a lump sum payment at a present time. Also, the regular payment, you know, comes in $30,000 for every 6 months for 20 years. Okay, so first of all, identify the present value of the annuity. And let's list all the given information. Regular payment is given 30,000. Time T is given 20 years. Number compounding period is given twice per year. And then interest rate is given 6.38%. Right. So basically we have all the information we need to perform a calculation. So the present value of the annuity is regular payment times 1 minus 1 plus R over N to negative NT. Over R over N. Yeah. So moving forward, we got 3,000 times 1 minus 1 plus 0.0638 over 2 and raised to negative 2 times 20 years. Okay, 20. That means this recipient of the trust fund received 40 times of $30,000 over the life of the trust fund. 2. Okay. And similarly, you just input it properly, we should get a result. So $30,000 right, times 1 minus 1 plus the rate is 0.0638 by 2 raised to -2 times 20 years. Close parentheses for denominator, and that's denominator is 0.0638 over 2. Okay, and that should give us the right result. Okay, and this result turned out to be okay, $672,629.31. That's the current value of all that cash flows, right, over the 20 years of time. $672,629.31. So go back. $672,072. Let's see the exact number. 29.31. 629.31. That will do it. Right. By having this much money deposit into account, find a good investment company for you, you'll be able to achieve the financial goal, right? In this particular scenario. So you basically provide some security for your loved ones or like your family members, make sure they'll be able to have sufficient funds. Okay. Okay. And the last question is about lottery, right? Also big, not big for everybody, right? But still, you know, some people win the lottery and then they have to worry about this, right? And suppose you win a 50 million lottery companies give you choice of 50 yearly payments of $1 million, right? You're getting 50 million, but every year you only end up with the 1 million or the equivalent lump sum now. The lottery company will calculate a lump sum based on 6.36% interest rate. How much will you be offered now? So again, you'll be getting a lot less, right? But still a lot of people take advantage of this. Still take one-time payment instead of 1 million per year. Because it just, first of all, you get a big payment coming in one time, right? One-time payment, big payment. Also, you know, you can utilize that amount of money to make it, to generate more money for you compared to 50 million, you know, in 50 years, you may end up with more money, right? So that's very possible. So this scenario is, let's find out the present value of the annuity, right? So it's present value of annuity issue. And we know that regular payment is 1 million. Okay. 20 is 50 years. Right? Number compounding period, meaning receive that 1 million once per year, so n equal to 1, and then the rate is 6.36%. And that's fine. Now, what is the equivalent present value of this series of cash flows? So now the present value equals regular payment times 1 minus 1 plus r over n to negative nt over r over n. Now one more time, we plug in the numbers. So a million by 1 minus 1 plus the rate is 0.0636. So again, we turn in a decimal number. And dividing by 1. And then this is 1 times 50. Okay. And denominator is 0.0. I'm dividing by 1, we can omit it, right? So it's not needed. We don't have to even write it. So this basically is 1 million times 1 minus 1 plus 0.0636 raised to negative 50th power and dividing by 0.0636. Let's see what that is worth right now. So it's a million 6 zeros, right? Million has 6 zeros times 1 minus 1 plus 0.0638, 636, 636. Okay, close parentheses and raised to negative 50 power and divided by denominator, and it should be 0.0636. And let's do it. Here you go. So actually you end up with okay, this is total amount of, let's turn into a proper form. It's 15 million as change, right? Yeah, currency. Okay, so it's 15 million, $2,782.94. That's how much it's worth right now. Okay, that's what that is. And we can make it bigger so you can see. So although you win 50 million, right? But it's only worth this amount right now. Okay, a lot less. But again, if you can find a better, investment opportunities in 50 years, this amount could grow to maybe 60, 70, or $100 million. They're all possible, right? So you do not limit the opportunity to the lottery company, but you take advantage, take your own destiny. You control your own investment strategy or everything, and you may be able to end up with a lot more money compared to 15 million. Okay, so that should give you some idea. If you have win a lot of money, from casino or maybe from the lottery companies, and that's how you handle this situation. All right, and that's pretty much everything in your review sheet. And you are taking that test number 2 on Friday. You have an entire class period to finish the question. Again, I will create Dropbox for you to submit your. I'll make sure you have access to the test number 2 on Friday. Okay. And do you have any other questions? We still have some time. So if you want me to go over any question from your homework, I'm more than happy to do that.
Yeah, Professor, I'm actually having trouble with the question 15 on homework, exercise 3.4.
Great, so let's look at it. 3.4, 15. Oh, I see. Some of the question, we may not even cover that, so you can skip it. I think that is not the question.
Oh, okay. Okay, so if I can skip it, that's fine.
Okay, so let me go there and then let me tell you where you can stop. In terms of section 3.4, right? Every other section is good.
Yes.
For section 3.4, you only need to complete up to amortization. That's the only thing I cover, like exotic mortgages and some other topic I didn't cover, interest-only mortgage and a housing crisis. If you are interested in that, you want to know the detail behind financial crisis in 2008, and this is good reading for you. If you want to dig deeper, let me know. I can provide some, detailed information about this, but you can basically omit those. So let me go to the question exercise in the back of the 3.4. So 3.1, 3.2, 3.3, all the are problems, right, from in the back of the exercise. And 3.4, yeah, this is 3.4, all the way up to question.
Yeah, that's it.
Right? Yeah, that's it. So all the R numbers,
Okay.
question 12, everything else, don't worry about it. Okay, you can skip it.
Sounds good.
Okay.
Thank you.
All right, but I can, if you really want me to go over this, I can go over that. Totally up to you. Okay.
No, that's fine. It's fine for me.
Okay, that's cool. Yeah. Any other questions? Want me to review?
I have a question.
Definitely, yeah.
So it's next Friday that
No,
the homework and the test
coming
is
Friday,
going
right? Coming Friday. What I mean is
this Friday
16th.
coming up in 2
Yes,
days?
16th, right? So
Okay.
the good thing is we review today. You have a couple of days to refresh your memory. So on Friday, if we do it next Friday, you may forget some of the contents. So it's better, you get it done right away. So you still remember everything, and you can focus on just study for that, and you will be able to do well. Okay, so 16th, right? This Friday, 16th. You're taking the.
So, Professor, I have another question.
Definitely.
So you just said to do all of the problems for 3.1, 3.2, and 3.3. But in class, you told us, like another time in class, you told us only to go to question number, I believe it was 21 for 3.1.
Okay.
So should we
I tell you
do
that,
all of one?
then that's the seed. Okay, that means that's the seed from what I talk. So let me go there. Don't worry. Let me take a look at. If I ask you to skip it, you can skip it definitely. But I probably forget about that. So let me look at the exercise really quickly. Yeah. Oh yeah. This is exercise 3.2. Yeah, that's all those questions are good questions. All the problems. And 3.1. Okay. This is 3.1. Yep. Did I mention that? Okay, if I mention that, then you can. Which question do I ask you to skip?
You only told us to do the odds from 1 to, I think it was 21. I wrote it down.
Fine. Yes, that's okay. Yes, and after 22, you can skip it. That's okay. So section 3.1 all the way up to question 21. Let me make a note and then create a Dropbox for you, so you're not confusing about what questions to submit for your in terms of the second homework assignment. So let me just create a Dropbox here right now. So homework number 2, I will list all the details on a comment section. Homework number 2 from section 3.1 to 3.4. Okay, so for section 3.1 up to question 21, right? No problem. And section 3.2, all are questions. And section 3.3, all are questions. And then section 3.4, only up to question 11, right? Yeah. And if you finish those already, you can submit it, right? No problem. You don't have to wait until Friday, but you have until Friday to submit it. It also help you prepare for the actual test number 2, because the questions are very, very similar. up to question 11. Okay, let me highlight that so you know what to go by. All right, but thanks for reminding me. I almost forget about that part. I forget I mentioned that. Yeah. So good to know. Okay. And yeah, so any other questions besides this, right? So yeah, make note so you know how to follow. Okay, very good. Anything else you want me to go over in your homework assignments? All right, in that case, if you have no other questions, feel free to go, right? I'll post this review videos shortly once I finish producing this. And if you need to go back that and then take a look at some of the questions, you didn't catch during the class, you can do that. All right, so if you have individual questions, you can stay after class, talk to me. Otherwise, feel free to leave. I see you guys. I'll talk to you guys on Friday. Bye-bye.
Thank you, Professor.
Okay, no problem, guys. Bye. Okay.